Today's topic is isotope notation, but before I actually get into that, I want to just do a little quick side note for you for something that you're actually going to see in your reading for tomorrow, and that is because of some of the diagrams that are shown on page 60 of your book where they're talking about electrons and how electrons are in the atom, and the diagrams that they have, they don't really explain where those diagrams came from. So I want to show you where the diagrams came from so that hopefully when you read that tomorrow it's going to make a little bit more sense. We talked earlier that we said that when we draw the diagrams for atoms on paper, what we tend to do is we tend to put protons and neutrons in the middle, in the nucleus. And so your protons and neutrons are in here. And then we tend to draw these others out here as orbits going around like that, knowing that that's not really the way it is, that it's more of a big electron cloud, but it's a little bit easier to see this way, a little bit easier for us to comprehend it. Now, in order to understand their diagrams, what you have to understand is that each level that you go out, it's almost like the layers of an onion. Every layer that you go out is going to get bigger and bigger and bigger. So it would be logical then that each layer that you go out is going to hold more and more electrons. In fact, you may have noticed this even when you did your experiment with the simulation online, where you saw that you could start dragging electrons and dropping them in. And you may have noticed that in that first energy level that's the closest to the nucleus, you couldn't ever get it to take any more than 2. And then all the rest of the electrons went into the next layer out. So that's where a lot of this comes from. So if your nucleus is right here, the first energy level that holds electrons can only hold 2 electrons. That's all the bigger it is. And remember that, electrons all have, just like we talked about how protons all have the same charge and they repel each other. Well, electrons also all have negative charges, and so they're going to repel each other. They're going to stay as far apart from each other as possible. So in order to stay as far apart as possible, there's only going to be 2 that are going to go in here. Now, when you get to the second energy level, the second energy level can hold up to 8 electrons. The third energy level can hold as many as 18 electrons. And then if I go one more energy level out, it can hold as many as 32. Now, this is not something that we're going to spend a lot of time on. It's not something that I expect you to remember, but I wanted to explain it to you that each succeeding level, energy level for the electrons will hold more and more electrons, just so that those diagrams will make a little bit more sense to you. Again, this is something that we'll talk about a whole lot more when you take chemistry. But for right now, all you need to understand is that the further out I go, the more electrons, each energy level can hold more and more electrons. Okay, so let's get rid of this up here. And the main topic for today is actually isotope notation, as I've written right over here, isotope notation. When we write isotope notation, what we're going to do is we're going to write a symbol for the element, and I'm just using E to symbolize element. What's up at the top is going to be the mass number, and what's going to be down here at the bottom is going to be the atomic number. So the mass number goes at the top, atomic number goes at the bottom, right next to the symbol for the element. We're going to do several examples of this. So again, you're going to need the day 5 worksheet that I told you to have and your periodic table, and we're going to do the first several rows together so you can understand how this works. Okay. With isotope notation here, you can see the symbol for the element right here, and we've worked with an H before. If you look at your periodic table, it's up in the top left-hand corner. You know that that's hydrogen, and so the name of this is going to be hydrogen something. You know what? I should have done that in red so that you know that's the one I'm filling in. That way I'm consistent with what I did before, right? Consistency is a good thing. So we'll put hydrogen here. That's the name. And what always goes after that? Well, that's always the mass of the isotope. And what I told you was, well, the mass number is on the top, so whatever number is on the top over here, that's the mass number. So this is going to be hydrogen 3. What's the atomic number for hydrogen? Well, it should be the number on the bottom, and that should also agree with the atomic number on the periodic table. And if you look in the upper left-hand corner for the hydrogen box, just like you found atomic numbers before, you'll see a 1. You'll see that there's a 1 down here. So the atomic number is 1. How many protons does that mean there are? Well, the atomic number and the number of protons always match, so there's 1 proton. And we said that for right now, all the atoms we're looking at are neutral, so the number of protons and the number of electrons are going to be the same. Day or two, that's not going to be the same anymore, but for right now, they're still the same. The mass number was what's on the top, so I can fill the mass number in. Mass number is 3, because that's what's on the top over here. That's what's right here. So how many neutrons does that mean I have? Well, number of protons plus number of neutrons equals the mass number, so 1 plus what makes 3? Well, if I subtract 3 minus 1, that's going to give me 2. Go back and check. 1 plus 2, that's going to make 3. Okay? All right. Next one, I've given you the name this time, carbon 14. Carbon is in the second row on the periodic table. First thing you would probably look for would be a C, since carbon starts with a C, and you'll actually get to find it, if I can see upside down. Carbon is right there. And so if you look at that, you can see that the symbol is a C. This is the mass number, so we know that that's the number that's going to go on the top. What about the number that goes on the bottom? Well, that has to come from the periodic table. What number is up in the upper left-hand corner? Okay. Well, there's a 6 up there, right? So that means that that's what the atomic number is. So the 6 is going to go down here. And the 6 is the atomic number. It comes from the periodic table. How many protons does that mean there are? Yep, 6. How many electrons? Protons and electrons are the same for right now, so this is 6. That top number is a 14. What's the top number? The mass number. So that means I'm going to put a 14 over here in the mass number column. And the only thing I have left now is the number of neutrons. How do I find it? Well, number of protons plus number of neutrons gives me the mass number. So 6 plus what is going to give me 14? Well, if I subtract those two, that's going to give me 8. 6 plus 8 will make 14. Okay, so that one's all filled in. All right, the next row, I gave you the atomic number and the mass number. Well, the atomic number and the mass number, I know that that's the two of the pieces of the isotope notation. So that means if the mass number goes on the top and the atomic number goes on the bottom, I know it's going to have to look like that. And that's one way to help you remember it too, that the heavier one, the bigger number always goes on the top. So now what symbol goes there? Well, you need to look for, on your periodic table, you need to look for the element that has an atomic number of 8. So can you find that on your periodic table? Start looking through. Where's the one that has an 8 in the upper left-hand corner? You should find that right there. So there's an O in there. That's oxygen. And so I'll put an O here. And the name of that is going to be oxygen. Remember, the mass number goes after that, so it's oxygen 16. Atomic number is always the number of protons. For a neutral atom, it's also the number of electrons. So how many neutrons are in this atom? Well, 8 plus something is going to give me 16. What number is that? 8. All right? All right. Last one that we're going to do together today. You're given that you have 16 protons and 17 neutrons. So what does that mean? Well, I know that the number of protons and number of electrons for right now are going to be the same. I keep emphasizing that because I don't want you to get in too big of a habit, because a couple of days that's going to switch. So for right now, if I have 16 protons, I know that I have to have 16 electrons. What's the mass number? Well, the mass number is protons plus neutrons. Well, what's 16 plus 17? That makes 33. And if you need to use a calculator, I'm okay with that. Or if you need to go over to the right-hand side and add that together, if you can't do it in your head, I understand, that's fine. So 16 plus 17 is going to make 33. So now I have the mass number and what's the atomic number? What's the atomic number always match? Number of protons, right? So if the number of protons is 16, that means my atomic number is 16. Now I know the mass number and the atomic number, so I know I'm going to have a 33 on the top here and a 16 on the bottom here. Well, what element has an atomic number of 16? Well, again, you're going to have to go to the periodic table and find the element in the upper left-hand corner with a number of 16. And you should see here's 8, 9, 10. I have to go down to the next row. And then when I get down to sulfur, you can see that there is a 16 right there. So 16 is sulfur, so I'm going to have an S. And then this is going to be sulfur. And remember, the mass number goes after that. So it's sulfur 33. Alrighty. So I'm going to let you finish the rest of that. And then you will have, again, a few additional problems to work on just to make sure that isotope notation is really easy for you.